Word problems as proportions. The setup. Proportional means two ratios are equal. Another way to say it is one fraction equal to another fraction. The key to any proportion question is relationships. We need to make sure that the items in our fractions are related horizontally and vertically. Check the solving proportions presentation before continuing if you don't remember how to solve a proportion. We're just going to set them up in this presentation. We're not actually going to solve them. Here's an example problem. Sally studies 5 hours and scores an 80 on her test. If her grade is proportional to the time spent studying, then how long will she need to study to score a 90 on her next test? There are several ways to set up this type of problem. My preferred setup is this. So my fractions are events. And the numerators would be the same units. The denominator would be the same units. Okay, let's walk through this problem. We know that Sally actually studied for 5 hours and scored an 80. That's my event 1 because they go together. 5 hours studying, got an 80 score. So event 1 is actual test score and time studied. I'm going to put hours on top and the score on the bottom. It doesn't matter which way you go. Okay? But since I set it up this way, hours on top, score on the bottom. In my second fraction, event 2, I need to find out how many hours are studied to get the score of 90. So I have partial data in this information. So event 2 becomes desired test score and desired time studied. The data I have is a 90 on the score. Since 80 is on the bottom, the denominator, then 90 has to go in the bottom because it's also a score. So they're related by units, percentage. So the numerator is hours studied. I use an X to represent the unknown value. So I'm related vertically. The first fraction, 5 over 80, is what she actually did. The second fraction, X over 90, is what I'm trying to find. Related horizontally, hours studied across the top is the numerator, and then the denominator is the test score, percentage is the units. So this would be the proportional setup for solving this problem. Again, check the solving proportions presentations if you do not remember what to do from here. Now, this could have been written several different ways. Okay, we just did it like this: 5 over 80 equals X over 90, where event 1 was actual, studied, and test, and event 2 was desired. The numerator were hours, and the denominator was score. But we could have set it up this way. In other words, on that initial fraction, I could have flipped it. I could have put score on top and hours on the bottom, which would then change the second fraction to 90 over X. Or maybe I switched it around and I put the scores as my first fraction. and then hours studied would be my second fraction. Notice that the denominator is the actual data, 80 score from 5 hours study. The numerator is the desired data. I wanted the score of 90. How long do I have to study? Again, everything's related. Related vertically. The first fraction is score. The second fraction is hours. The numerator is the event 2, or the desired amount, and the denominator is the actual that was given in the data. Or we could have written it this way, where the first fraction is hours studied, 5 over an unknown quantity, and the second fraction could be score on test, which would be 80 over 90. Again, the numerator is related because it's the actual data, and the denominator is related because it's the desired event too. Okay. My personal setup is always doing the events as a fraction. Now let's try this problem. Steve's car will go 258 miles on 12.3 gallons of fuel in highway driving. How many gallons will it take to drive the 1,613 miles to his Aunt Jane's house? Well, we know that Steve's car can go 258 miles on 12.3 gallons of fuel. So I'm going to use that as event 1, my first fraction. Actual miles driven and fuel used. So I'll put miles on top, 258. Gallons on the bottom, 12.3. Now I need event 2. Well, I don't know how much fuel, but I do have the number of miles. So that becomes the data I'm going to use to set up event 2. Desired miles driven and fuel used. I have the miles, 1,613, so both numerators are now miles, and the denominator's gallons. I don't know what the number of gallons are for this. So there's my setup. 258 over 12.3 equals 1,613 over x. Again, remember, check the solving proportions presentation if you do not remember what to do from here. Example 3. For every 5 pounds of body weight for a certain animal, there are approximately 4 pounds of muscle. For an 111-pound animal, how much of the weight is muscle? Well, we know that 5 pounds of body weight have 4 pounds of muscle. So I'm going to use that as event 1. Actual muscle and body weight. I'm going to put body weight on top and muscle on the bottom. I can't use pounds because they're both pounds, so I can't use the units, so I have to use what they represent. But body weight on top, muscle on the bottom. And for my second event, I know that I have a body weight of 111 pounds. So that's the data I'm going to use for event 2, desired muscle and body weight. So I know I've got 111 pounds for body weight. And for muscle, I don't know, so I put an X. So there is the setup. 5 over 4 equals 111 over X. This is a proportional setup. And again, remember, check the solving proportions presentation if you do not remember what to do from here.